Now we have shots for our player to shoot, so let's enable our player to shoot them. For this assignment, we will need our player game object. So select Player and reactivate the player game object. Next, we need to edit our player controller's script. There are several different ways that we can open a script for editing. In this case, with the player selected, use the context-sensitive gear menu on the player controller component and select Edit Script. This will open our script in our script editor. We want our player to shoot shots into our scene. We have saved our shots as a prefab game object in our project. This is an asset that we can use when our game is running. What we need to do is instantiate a copy or clone of this shot prefab when we hit a button or click a mouse during our gameplay. Where are we going to write this code? Well, simply getting input from a button doesn't require physics, and we don't want to wait for a fixed update to fire our weapon. So let's put our code in the update function. Write void update. Unity will execute all of the code in update just before updating the frame, every frame. Now, we want to instantiate our shot. How do we use instantiate? Well, let's check the documentation. The shortcut to Unity's scripting reference in the documentation is Command plus single quote on the Mac and Control plus single quote on Windows. And choose Object Instantiate. For more detailed information on instantiate, please see the lesson linked below. Instantiate needs an object to instantiate and a position and rotation to set the object to when it is instantiated in the scene. So let's write object, position, rotation. We know what object we want to instantiate. That's our bolt prefab. Where, on the other hand, will we find a position, which is a vector 3, and a rotation, which is a quaternion, to set our object to when it is instantiated? There is one compact package where we can find both a position and a rotation, and that is in a GameObject's transform. The transform component contains a position as a vector 3 and a rotation as a quaternion. The transform also includes a scale as a vector 3, which we can ignore for instantiate. In the inspector, the quaternion for rotation is simplified as a quaternion Euler. For more information on quaternions and quaternion Euler, please see the lesson linked below. So how do we use this to instantiate a shot? Create a new empty game object. Rename it ShotSpawn. We can use this empty game object's transform as a spawn point in our game. We can think of this as some sort of virtual hardpoint to attach our weapons to. This spawn point should move with our player's ship. So let's drag ShotSpawn onto our player game object and drop it as a child. If we open the player game object family, we can see the ShotSpawn in the hierarchy as a child game object. Let's switch to the scene view for a good look at our player ship and the ShotSpawn game object. We can now position the ShotSpawn. As it's a child of the player's ship, our ShotSpawn's position will be relative to the player's ship. We want to instantiate our shots in front of the player's ship. So let's drag the ShotSpawn out along its z-axis until it's in front of the ship. Let's make this around 1.25. If we want to test the position, we can drag an instance of our bolt prefab into the scene as a child of ShotSpawn. Make sure the instance's transform is at origin. This is a local value, so it will be at origin relative to the ShotSpawn's transform. This is where the ShotSpawn's position and rotation will put our instances. That's great. That feels good to me. Now, let's make sure we delete our test instance We don't want to have a shot in our scene when we start the game. Let's return to our player controller script. Now, we need to write a few variables to hold references to our object and transform. Write public GameObject shot and public GameObject shotSpawn. There may be a better way to handle shotSpawn. If we reference the GameObject to get the position and rotation we need, we would have to write shotSpawn.transform.position, and the same for rotation. On the other hand, our variable could use the type of transform instead of GameObject. We will still drag a reference using the GameObject in the inspector. But Unity is smart enough to find and use the transform component on that GameObject if we declare the variable's type as transform. So what do we want to instantiate? Our shot. And where do we want to instantiate it? At the shotSpawn position with the shotSpawn rotation applied. If we left the code like this and tested it, we would create a stream of shots. One new shot every frame. For this game, let's fire a shot only when the player holds down a fire button. And we will limit the fire rate as well to a value we can set in the editor. We do this with input_get_button. Let's look up input_get_button in the documentation. Conveniently, the code snippet in the documentation is all about firing a weapon and limiting the fire rate. Let's step through this code one line at a time. The example starts with a GameObject reference, like our shot reference, followed by a float value to set the fire rate, or how long we must wait between shots. Lastly, there is a next fire value, which is used to track when in the game we can fire our next shot. Let's look at the code in Update. We only execute the instantiate code and fire a shot if input_get_button is true and the time in the game is greater than our next fire value. The fire1 used in the input_get_button code is a value preset in the input manager, and the time in the game is represented by time.time. For more information on the input manager or the time class, please see the lessons linked below. What is the key to this code is that as soon as the if statement returns true, for both the input.getButton and time.time, the next fire rate is updated, which prevents us from firing again. All of the code in Update will be executed every frame. On the very first frame, time.time will be greater than 0, so we could fire as soon as we touch the fire button. But let's say we don't touch the button until 1 second into the game. On every frame before that 1 second mark, time.time will never be tested against next fire, as input_get_button fire1 will be false, and this statement is tested from left to right. When we do touch the fire button, input_get_button fire1 will be true, and time.time at 1 second will be greater than the next fire value of 0. So we fire our first shot. However, in the same frame, we increase the value of next fire to time.time plus fire rate, or 1 second plus 0.5. Next fire is now 1.5. If we keep our finger on the fire button, in the next few frames, input.getButton will be true, but time.time won't be greater than next fire. We won't be able to shoot another shot until more than 1.5 seconds into the game. So, let's copy the sample code from the documentation and paste it into our script. There is one typo in this C# code snippet that we need to correct. We only need asGameObject once in our code. What is this asGameObject code for? We need to remember that we are simply instantiating a basic object with our code. Unity does not know what type of object this is. we could have defined this object in a number of different types. To access and use this object, we need to tell Unity what type of object it is. So what we are saying with this line of code is, please instantiate this basic object as a game object. When we instantiate an object, we can take a reference to that game object. The instantiate function will return or give us a reference to the object we are instantiating. We take that reference here with our GameObject variable at the beginning of the line. This gives us a connection to the new object as a game object. Otherwise, the new object just gets dropped into our scene along with all of the other objects that we have. Without a reference to the new object, we cannot easily find and pick this object out of all of the others in the scene. If we don't have a connection or a reference to a specific object, we cannot perform actions or do things with this object. If we take the reference to the new object when we instantiate it, we now have access to that new object. Now, in our case, we are simply firing our shots into the scene. We don't need to do anything with these shots once we have fired them. They can take care of themselves. We don't need a reference to the shots we fire, and we can get rid of the reference and simply instantiate the object. When we do, we must also get rid of the asGameObject as well. Now, let's update the sample code we've pasted into our script. We want to instantiate our shot at the shot spawn position with the shot spawn rotation. Next, we need to update our variables to work with this code. We need a public float for our fire rate and a private float for our next fire. Now let's save this script and return to Unity. Click on the player game object so we can inspect it. We need to populate the references we have created in our player controller script. Open the prefabs folder and drag the bolt prefab onto shot. Next, grab the shot spawn game object from the hierarchy and drag it onto the shot spawn reference on the player controller component. Note that Unity was able to reference the transform component from the shot spawn game object. Lastly, we need to set our fire rate. 4 times a second sounds good and fast, so let's use 0.25. Now, let's save and play. And we're shooting our shots. And as we move, because the shot spawn is a child of our player ship, we always shoot from the front of the ship, no matter where we are in the game. Our player can now shoot shots. We have created a problem, however. We are filling our scene with shot game object clones, all flying off to infinity on the Z-axis. In the next assignment, we will create a boundary to clean up any game objects that leave the game area.